Hello my dear friends, this is Bandi Srinivasulu from My Physical Science Guru. In this video we are going to have a glance on the fantastic interactive simulations for practice. In this video, these simulations are corresponding to PhET Colorado interactions. Welcome to Simulations World. This is PhET Interactive Simulation. In this, we explore the simulations. We have to browse the simulations. If we want to have a translation, we can get it, otherwise no problem. And here is physics, chemistry, mathematics and earth science, biology. Now I myself is physics. I will take one of the physics simulation here. I'll go for energy simulation. Here energy skate park. If you touch the simulation, you will get it, and if you touch it, the interactive simulation will be downloaded. PhET interactive simulation downloaded on this IFP panel. Now you see this introductory part. If I touch the introductory part, like this, the simulation display is like this. You can, if you want a grid, you can take the grid. Then reference height. Reference height is this. You can move it up to which height if you want to show the simulation. So this much, if it is okay, then put it like this. Then what to do is, normal portion I have selected, and then here we can see the speed and the path. And now I selected this type of curve, and now there is no friction, and gravity is medium, and the mass is 60 kgs. I have selected this person here, and I am putting on this platform. Now see the energy park. When he reaches the height, you will get a potential energy that is get converted into kinetic energy. This is one way of showing the transformation of energy, potential to kinetic, that is mechanical energy. This is what is energy skate park. And now you can show some friction. Then the friction, if it is more, then the slow will be the movement of the skating. See, if I reduce the friction, the movement will be very fast, like this. So based on that, you can observe the speed of the person. So it is varying, and when he reaches the height, he gets potential energy. When he comes down, that potential energy gets converted into kinetic energy. This is a wonderful example for interactive PhET simulation, energy skate park. One more interactive simulation in physics, that is geometric optics, especially ray optics, where the image is formed using a convex lens. Just download by touching the center one, you will get the PhET simulation, PhET interactive simulation get downloaded. After downloading, touch the lens. Now you have here some of the important things. That is, if you want 2 to 3 rays, this is enough. If you want to show principal axis, you have a principal axis here at the center, and then if you want focal points, you can label it and work out the labels. Here is the convex lens, here is the object, here is the image formed. Just by moving, so you can show the where the object is placed, where the image is formed. Now starting from the object placed beyond, this is the place where I placed the object. Object is placed beyond 2f, then the image is formed in between f and 2f. This is the real image and inverted. Then I move this at 2f, I place this image object. So now the object is at 2f. Now the image is at 2f. The same size, and it is inverted, real image formed at the center of curvature. Here also placed the object at center of curvature at 2f, and the image is formed at the same place 2f. Size of the image is equal to size of the object. This is another position of the object which is placed. Then if you make it to put it in between f and 2f here, what happens? You observe. The image is formed beyond 2f. Here is the image formed beyond, and this is a real inverted enlarged image. Those are the images. And now I am moving the object at f. It is exactly at f. When it is placed at f, what happens? This is at f means the image is formed at infinite distance. You can't observe. The rays are parallel. They won't intersect. That will be formed at infinite distance. That means if it is at focus, the object is at infinite distance. For example, if you focus the rays of convex lens on the paper burn, and that is the focus, and that is the point sized image of the sun. Sun is at infinite distance, just like that. And then move this object in between what is called focus, focal point, and optic center. Then the image is formed behind the object, virtual image, erect and enlarged. You can observe the image size. This is what is you can observe the image size. This is the place where you will observe. Image is formed behind the object, that is virtual image, erect image, enlarged image is formed. This is by which we can, this is the way, if you change the position of the object, the size of the image changes. If it is at 2f, focus, infinite distance, in between f and 2f it is beyond c. At 2f it is at 2f, and if it is beyond 2f and the image is in between f and 2f, you can change the image object either pencil, or you can put it as arrow. So arrow is at the 2f, image is formed at 2f, beyond 2f, in between f and 2f, and if the image, if the arrow mark is placed in between f and 2f, you will find beyond the 2f the image is formed. If it is at f, so that is you will get it that is at infinite distance, the object is at focal point, infinite distance, the image is in between f, in between in between focal point and optic center you will get behind the object virtual image, erect image, enlarged image. So we can change the shape of the object. You can put star, penguin, arrow and light. So you will get the okay. You can measure the distance also. Suppose if it is 2f, so you can measure by taking the scale here. You can take the scale. If you put the scale here, you can measure. This is the object distance. Almost it is the total object distance is 160 here. Here also, if it is same object distance is equal to image distance, that is 160, and focal length is 80. Focal length of the lens is 80 from optic center to the focal point 80 centimeters. Like this you can use a scale for measuring object distance, focal length and image distance and radius of curvature.
లైక్ చేయండి, షేర్ చేయండి, సబ్స్క్రైబ్ చేయండి. మై ఫిజికల్ సైన్స్ గురు. థ్యాంక్స్ ఫర్ వాచింగ్ మై ఫిజికల్ సైన్స్ గురు. దిస్ ఈస్ బండి శ్రీనివాసులు ఫ్రమ్ అనంతపూర్.